Students, happy to see you, and it seems that my teaching is interesting. That's why all of you here, I think, Shai, am I correct? Okay, now in your notes, page number 30, we are going to discuss. Okay, we know what is generative function, and what is recurrence relations. What is a generation function or generative function and recurrence relations. Okay, now it is possible to use the generative function to solve recurrence relations. It is possible. Okay, how is that? By taking an example, I am going to discuss about this connection of recurrence relations. Some problems, recurrence relations and generative function. So generative function is helpful to solve recurrence relations. Okay, now this is what a recurrence relation given to us. AK equals 3AK minus 1. The particular current element equals 3 times its previous elements. Therefore, this is a recurrence relation for k equals 1, 2, 3, dot, dot, dot. And for k is equal to 0, the value is 2. For k is equal to 1, A1 equals 3 into A0. And A2 equals 3 into A2 minus 1, that is A1, like that. This is recurrence relation because each term comes from its previous terms by multiplying a number, dividing by number, whatever it may be. Therefore, it is a recurrence relation. Now we have to solve this. Already I was discussing about what do we mean by solving this recurrence relation. Okay, solving means to find out the sequence which satisfy this particular recurrence relations. Okay, of course I will show you. Yeah, this is what AK equals 2 into 3 power k. That is, this is the corresponding sequence for different value for k is equal to 0, 1, 2, 3, and that will give you sequence. Am I correct? Okay, understand that? And that sequence will satisfy this recurrence relation. Okay, after discussion, let us solve them. We know already gx equals summation ak x power k. This is the definition of generating function. Suppose I multiply by x. What will take place? This particular summation will become like this. Am I correct? K is equal to 1. Then you will get a naught x power 1, like that. X you are multiplying. Therefore, the summation will start with 1 and then end with infinity. It's not an alpha. This is an infinity. And this k becomes k minus 1. Okay, so if you multiply this x, you'll get a new expansion, and that expansion will be equal to this. So g of x equals summation k tends to 0 to infinity ak xk. When you multiply by x, x of g of x will become summation of k tends to 1 to infinity ak minus 1 x power k. Now g of x minus 3 into x into g of x. G of x is here, so summation of k tends to 0 to infinity ak x power k minus 3 times x into g of x. That is x into g of x is this. Therefore, minus 3 into summation k tends to 1 to infinity ak minus 1 x power k. Now look at this. In these two, which is if you take this k tends to 0, one term, that is a0 x power 0 outside, then this and this will become common. Am I correct? Then if you take 0, one term, plus summation k tends to 1 to infinity ak x power k, you will get this term. Am I correct? And this and this will become common, and you will get a naught plus summation k tends to 1 to infinity ak, this ak will come here, minus 3 times ak minus 1 xk common. We are writing the common terms here. So this step comes from this step, just taking one term this outside, a naught x power 0 plus, then both are coming common. That common summation comes here, k tends to 1 to infinity. Here ak comes minus 3 times ak minus 1, and xk is common, that bringing outside. Now what is a naught? You go back to the initial condition here. When k equals 0, ak equals 2. That's what the conditions given here. Am I correct? When k tends to 0, a 0 equals 2. When k equals 1, 2, 3, according to this rule, the regression relation is defined. So at the place of a naught, I am putting here 2. I am putting here 2. Now look at this. What is this? What is this? Becomes 0 here. How? Look at this. ak equals 3 ak minus 1. Bring this side. ak minus 3 ak minus 1 becomes 0. Am I correct? Therefore ak minus 3 ak minus 1 becomes 0. So that is 0 here. Because this can bring this side, as a result you will get ak minus 3 ak minus 1 0. So this term 0, you will get 2. So g of x minus 3 times x into g of x equals 2. That's what we get here. G of x minus 3 of 3x gx equals 2. Okay, right. So g of x minus 3x g of x equals 2. G of x is common, therefore we can write it as 1 minus 3x into g of x. 1 minus 3x into g of x. Okay, so that's the common factor is g of x. That's brought outside. Remaining elements here is 1, and remaining element here is minus 3x to g of x. So 1 minus 3x g of x equals 2. Therefore g of x, bring this down, you will get g of x equals 2 by 1 minus 3x. G of x, from here you have to come here. 1 minus 3x g of x equals 2. Therefore g of x equals 2 by 1 minus 3x. 2 by 1 minus 3x. So we'll get, this is denominator, we can bring it up like this, that is 2 into 1 minus 3x to the power inverse. 1 minus 3x to the power inverse. 2 is constant, we can bring it out. At this expansion, already we know that, am I correct? The expansion of this is nothing but 2 into 0k, 1 will come there, 1 plus 3x plus 3 squared x squared plus 3 cube x cube plus dot dot dot. That is the expansion of this. Am I correct? Like a power series. Go back and see there. We have studied so many examples like this. Now look at that. Now look at this. 1 minus ax power inverse equals 1 plus this term ax to the power a1 x1 plus a2 x2 plus dot dot dot. Okay, now look at this. 1 plus ax power 1, ax power 2, like that will go on. The same idea we are applying to expand this. To expand this, we are applying the idea. Therefore, g of x equals 2 times 1 plus 3x power 1 plus 3x squared plus 3x cube plus dot dot dot. Okay, so that is extended form, and this is the short form of the extended form. Okay, 2 is common here, 2 constant, and you expand this, and that short form is this. Summation of x tends to 0 to infinity. Expand this, what will get? K is equal to 0, 0, 3 power 0, x power 0, 1, 1 plus k is equal to 1, 3x power 1, k is equal to 2, 3x square plus 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 plus. Now bring this constant after the sum. Both are equal, am I correct? Here the sum is multiplied by 2 is nothing but the individual element is multiplied by 2. That's what the rule says. So we can bring this 2 without loss of generality. 2 into 3 power k x power k. Now look at this. This is g of x, generating function. Generating function is summation of k tends to 0 to infinity, 2 into 3 power k x power k. 2 into 3 power k x power k. If this is a generating function, what is this? You leave this xk. This is ak. Let me correct. The sequence ak, the sequence for which g of x is the generating function. This is a sequence for which g of x, that is 2 into 3 power k xk plus dot 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 summation. So this is what the sequence. Am I correct? So this is what ak, or we can take an like that, or ak. So ak equals 2 into 3 power k. 2 into 3 power k. Okay, yeah, 2 into 3 power k. This is ak. So this is the solution for this particular relation given to us. I mean, this is a sequence for k is equal to 0, for h equal to 1, for h equal to 2, for h equal to 3, you'll get a sequence. Am I correct? Those sequence definitely satisfy this relationship called recurrence relationship with this initial condition. Therefore, the solution of ak equals 3ak minus 1 is ak, that is 2 dot 3 power k, 2 into 3 power k. Okay, so this is the solution for that particular problem. Okay, I will come with another problem after some time. With that, I come to the end of this class. Thank you very much for being with me for the past some 15 minutes. Thank you.